In this lesson, we're going to apply trigonometric sum and difference formulas. Given the following, cosine alpha equals 8 over 17, and alpha lies in quadrant 4, and sine beta equals negative 1/2, beta lies in quadrant 3, we want to find A, the sine of alpha plus beta, B, the cosine of alpha plus beta, and C, the tangent of alpha plus beta. We need to start off by knowing what all the trigonometric functions sine and cosine are for each alpha and beta. So let's go ahead and find sine and cosine for alpha. We already know cosine of alpha. It's given to us. So if the cosine of alpha is equal to 8 over 17, and we know that it lies in the fourth quadrant, there's our alpha in quadrant 4. What we're going to do is go ahead and draw a right triangle in here so that we can determine what our missing components are. So cosine alpha, that's x over r. Well, we know that x is this piece right here, so that's going to be 8. We know that r is 17, and now we need to find y, and the reason that we want to find y is because we need to know what the sine of alpha is. And we know that the sine of alpha is going to be y over r. Okay? So let's go ahead and calculate that real quick because we're going to have to use a Pythagorean theorem. So this is y. So using the Pythagorean theorem, we're going to end up with 17 squared is equal to 8 squared plus b squared, which means that b is going to be equal to plus or minus the square root of 17 squared minus 8 squared. And I'm using plus or minus because every time you take a square root, you have a primary or positive root and a secondary or negative root. And in this case, the sign is important because we know that in the fourth quadrant, the y value has to be negative. So I'm going to end up with a negative value here. So b is going to be equal to negative square root of 289 minus 64. So b is going to be equal to negative square root of 225. The square root of 225 is 15, so b is equal to negative 15. Now, I could have just as easily, instead of using b, I could have used y here. And in fact, in order to remain consistent, that's probably what I should have used. Which means that I now know that the sine of alpha is negative 15 over 17. Now, I could go ahead and calculate the tangent, but I don't really need to, and I'll explain that a little bit more as we get to finding the sine, the cosine, and the tangent of the sum of alpha and beta. So this was part A, or as far as I should say, number 1. And that's this right here. So number 2 is the fact that the sine of beta is equal to negative 1/2. We know that beta lies in the third quadrant. So that means that if it's in the third quadrant, both x and y are negative. So once again, I note that this is going to be equal to y over r. So I know that y is equal to a negative 1 and r is equal to a positive 2 because the radius is always going to be a positive value. So that means that I'm going to use the Pythagorean theorem once again. So let's go ahead and draw axes. I know that my angle is in the third quadrant, which is this. And that's my beta. And now I can go ahead and determine what the missing component of my triangle is. So y in this case is a -1. The hypotenuse, or r, is a +2. And so I know that r squared is equal to x squared plus y squared. And I could have written that down over here when I was getting ready to do the problem, and I probably should have, just to make sure that I'm plugging everything in the correct place and order. So if r squared is 2, if r is 2, that means that this is going to be 2 squared is equal to, I have no idea what x is, plus -1 quantity squared. So I end up with 4 minus 1 is 3 on the left, x squared on the right, therefore x is equal to a plus or minus square root of 3. Now in this case, since we are in the third quadrant, we know that x is negative, so that means that this is a -3 right here. And now I can go ahead and I can find my cosine of beta. And the cosine of beta, we already know the cosine is going to be x over r. We know that x is, and that should have been a negative square root of 3. I don't know why I put 3 there. And so x is a negative square root of 3. R is a +2. And that gives me my sine and cosine. Okay, so now what we're going to do is actually calculate our sine alpha plus beta, cosine alpha plus beta, and tangent alpha plus beta. So, keeping in mind that sine of alpha was equal to -15 over 17, and that cosine of alpha is equal to 8 over 17, and that sine beta was -1/2, and cosine beta is negative square root of 3 over 2. And we're going to use the fact that A is going to be sine of alpha plus beta, and we're going to use the following relationship, which is going to be sine alpha cosine beta plus cosine alpha sine beta. Then we want to find cosine alpha plus beta, and we'll use this relationship of cosine alpha cosine beta minus sine alpha sine beta. And for tangent of alpha plus beta, you'll notice that I didn't go ahead and calculate tangent alpha or tangent beta. And what I'm going to do is, instead of using the sum formula for tangent, which would be tangent alpha plus tangent beta over 1 plus tangent alpha tangent beta, instead of that, I'm simply going to use the fact that the tangent of alpha plus beta has to be equal to the sine of alpha plus beta over the cosine of alpha plus beta. So let's go ahead and do part A. And since we already know what sine alpha is, we're just going to replace sine of alpha with its value, which in this case is -15 over 17. And then we're going to multiply that by the cosine of beta, which in this case is negative square root of 3 over 2. We're going to add to that the cosine of alpha, which happens to be 8 over 17, times the sine of beta, which is -1/2. and then we simply calculate that. And yes, you're probably going to have to multiply all this out because it may or may not reduce, who knows. But what I'm going to do is I'm going to go ahead and multiply these out and hold off on reducing and then add the fractions together. For example, this first fraction is going to be negative times negative, which is a positive value. And then it's going to be 15 times the square root of 3 in the numerator over 17 times 2 in the denominator. Then I'm going to add to that this multiplication, which will be 8 over 17 times the negative 1, which is going to give negative 8 in the numerator, and then 17 times 2 is 34. So that means that the exact value, because that's what I'm looking for, is going to be equal to 15 square root of 3 minus 8 all over 34. And we're going to do that for the cosine of alpha plus beta. And so our formula is cosine alpha cosine beta minus sine alpha sine beta in order to find the exact value of cosine of alpha plus beta. So I know that the cosine of alpha is 8 over 17. Multiply that by the cosine of beta, which is negative square root of 3 over 2. I'm going to subtract from that the sine of alpha, which is negative 15 over 17, times the sine of beta, which in this case is negative 1/2. And so I just go ahead and multiply these out, and I end up with negative 8 square root of 3 over 34. And then this is a negative, 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 so it's a negative 15 over 34. Which means that this is now equal to 8 square root of 3 minus 15 over 34. And then to find the tangent of alpha plus beta, I'm going to use the fact that sine of alpha plus beta over cosine of alpha plus beta yields the tangent of alpha plus beta. And since I happen to know both sine and cosine alpha plus beta, we'll use the alpha, which is 15 square root of 3 minus 8 over 4 over 8 square root of 3 minus 15. And that should be over 34, not 4, over 34. The reason I knew that is because I knew that the denominators were going to divide out, which means that this is equal to 15 square root of 3 minus 8 over 8 square root of 3 minus 15. And that's your exact answer for tangent alpha plus beta.